Hello and welcome to the BS and Beer Show. BS stands for Building Science. We've been doing this now for 5 years, which is crazy. Tonight's topic is shear walls for anybody who doesn't know why they showed up. I'm Emily Mottram. Unfortunately, I don't have a cool bottle of wine tonight, so I'm drinking pineapple and coconut bubbly. BS and Beer is a grassroots independent movement to bring building science to you guys and hopefully have fun while we're doing it, bring our knowledge, local meetup groups, and our Zoom show. So the brew crew and our guests volunteer our time to do this, so we appreciate that everybody shows up and has fun with us. We encourage you to find a local group so you can pop onto our website and check out if there's any local groups near you or start your own local group if you want. More updates and resources coming on that if you guys want to start your own local group. Post your questions and comments in the chat box. I see it's starting to blow up. People, introduce yourself. Make sure that you select all panelists and attendees or everyone. Zoom will automatically go to hosts only, so no one will see that you're here unless you pick everyone. And our chat box moderator, Mike, will tell you in all caps when you don't do it correctly. So don't let Mike yell at you. You can find all of our past video recordings, over 100 shows on our YouTube channel, including this one if you want to go back and watch it 16 times again afterwards, on our website, thebsandbeershow.com, or over on the BS and Beer Show YouTube channel. You can find the audio version only on our website as well if you want to listen to it as a podcast. And just want to give a big shout out. I love to say we take this with no technical glitches and everything runs smoothly, but we do have some people in the background who help us make that happen. So big thank you to IMW Group for keeping us organized and getting the information out to you. And also Motif Media for taking the show and editing it and posting it afterwards so you can follow up after. So I'm going to, Travis was on announcements. So it looks like, Mike, you're going to do announcements.
I am drinking a Lone Pine IPA, one of my favorites. For announcements, we have the Building Science Symposium is happening next week in Sacramento, California on May 6th and 7th. There are still a few seats available, and it's a really good deal for high quality education. Speakers include luminaries such as Steve Bazek, Jake Bruton, Ross Trethui, our own Ben Bogie, and Dr. Joe Stiebrick. This is your last chance to experience this fun and educational event in the US until the fall, when it returns to where it all started in Kansas City in September. So get your tickets now, and I will throw a link, or somebody will, into the chat box. Also, notice I said in the US, our friends to the north are hosting their own Building Science Symposium, coming right up as well in beautiful Vancouver, British Columbia on May 21st. So if you're Canadian or in the Northwest, check that out. And also please follow BS and Beer Canada A on Instagram, and we'll put a link to that in the box. And if anybody else has announcements, please feel free to share those, and I will turn it over to Ben for introductions.
Sure. Thanks, Mike. So I'm Ben Bogie, builder in Connecticut. This evening, I am drinking a Kent Falls Sweatpants. So it's a local brewery to me. This evening, I have the distinct pleasure of introducing Mr. Thor Matteson. Thor is a structural engineer based in the San Francisco Bay Area, where he specializes in earthquake retrofits for vulnerable homes since 2008. He's the author of Earthquake Strengthening for Vulnerable Homes and several other resources focused on shear walls and residential resilience. Thor co-founded the Earthquake Bracing Academy, a nonprofit that teaches practical seismic strengthening strategies and has contributed to critical FEMA and California Earthquake Authority guidelines, including FEMA P1100. He also serves on the International Code Council Committee for residential earthquake retrofits. And you can learn more about Thor's work and the Magnitude 10 system at quakebracing.com. Thor, is there anything we missed there? And would you let us know what you're drinking this evening?
All right. I am testing out a bottle of wine that was made by a client of mine and given to me last week. So I just popped that open. We'll see how I do. I I'll try not to drink too much because it's only 3 o'clock here and I have some work to do for the rest of the day. And as one of my architect friends said one time, he was quite happy to know that his engineer didn't drink too much. So uh, just the right amount. Anyhow, so yes, I besides having the defective gene that makes me enjoy structural engineering, I also discovered I have another defective gene that makes me enjoy crawling under houses and seeing what was going on 100 years ago when they were putting them together. Really quite fascinating to see the craftsmanship from 100 years ago when they were using hand tools exclusively, and just admire what they were able to do back then. So this is the schematic of a shear wall. Should back up a little bit and say that in just about any structural system, whether it's reinforced concrete, structural steel, masonry, or wood, if you're talking about earthquakes, the method that those forces are resisted is through some sort of deformation of steel. Steel is at the heart of just about any structural system that we use for earthquake resistance. In the case of a shear wall, it's going to be hundreds or maybe thousands of nails that are around the edges of the panels, and those are going to bend as the shear wall deforms and absorb the earthquake energy. Wind doesn't flex so much back and forth, so you're not going to be getting the same bending action, but you'll be getting the rigidity from the plywood shear wall, and that's going to resist wind forces. So going through, I used to tell people there's really only one thing that you need to remember about shear walls. You just need to apply it along 4 different edges of the plywood panels. So the first is you need to transmit the force from the wind or earthquake to the top of the shear wall. You need to resist that force at the bottom edge of the shear wall. So that's where it's connected to the foundation or to the floor framing below. You also need to keep your shear wall from lifting up off of the foundation. So that's going to be through hold down forces. So you're going to have a nice Simpson bracket or something else at the end of the shear wall that connects it to the foundation. And at the opposite side of the shear wall, you've got to have something to prevent the end post on that side from punching down into the framing or somehow squishing the mud sill when it's got a compression force on it. So you're going to have, again, along the edges of the shear wall, you need to have enough fasteners from the plywood to the end posts that you can transmit those forces into the end posts of the shear wall. And I should let anybody feel free to interrupt with questions if you got them. Otherwise, I'll just keep moving along through.
Thor, we'll try and capture them out of the chat box and compile them, unless one seems like it's on fire and burning the house down with intensity.
All right. So what I've begun doing, since a shear wall needs to be several feet wide, and I was having clients in San Francisco and the Bay Area where the front of their house had, in some configuration, either a garage door and a service entrance and a stairwell, or you could mix those up and switch the order. But there was always, almost always, the front of that building was just openings and maybe gas meters and really no space to put a shear wall in place. So to accomplish any kind of bracing, you needed some other method of doing that. So this is sort of a classical, what's called a soft story building, where you've got room to park 4 cars, but you don't really have any room for a shear wall. So looking at that, we wanted to figure out a way to brace those. Hang on, I'm trying to bring up photos in a different window so I can see where I'm going next. We need to brace this somehow so that when an earthquake comes along, you're not going to be seeing this situation because there's no capacity for bracing here. So this kind of building does collapse pretty easily in earthquakes. The bracing methods, again, if you're using a plywood shear wall, you're going to cover up that opening. If you're going to put in a braced steel frame, you're also kind of annihilating any usefulness of that opening. I don't even know how that roll around dumpster gets back in there, but I guess it did at least once. Diagonal braces are just going to annoy people. So what I did was lying awake at 3 in the morning one time, I decided that you could introduce some sort of special bendy pieces onto a steel column. So this is the magnitude 10 brace, and I've actually got a little physical demonstration I'll show you in a moment. But the blue column there gets embedded into a new concrete footing, takes up very little space. There's a view of it from the inside of the carport. Those yellow pieces are precision cut 1-inch thick steel that is it's configured in a way that it will absorb the seismic energy in a really controlled manner. And so after the earthquake, you can unbolt those yellow pieces that are on both sides of the column and replace them, and you're ready for the next earthquake without, we hope, without having any of your cars crunched underneath the building. So I have got a model that I will demonstrate of that. So this would be the steel column that gets embedded into the foundation. This is showing the floor framing that's going to be up above the garage or the carport. And this is, of course, the steel piece that's going to be bending during the earthquake. So as the earthquake slides the building above back and forth, the yellow piece is absorbing the energy. And when your building stops moving, it may stop over in this position, but you can winch it back into place, unbolt this part, put replacements on, and you're good for the next earthquake, which is a lot easier than replacing a welded steel frame or some other kind of bracing system. So the idea is that you'd be able to get back in business, reoccupy the building a lot sooner than you would if it was some other system, or worse yet, if there was no earthquake bracing and you had a situation where the building just couldn't even be occupied at all. So that's where I've come from shear walls. Really, you can get 16 to 20 feet of plywood. The strength of that collapsed down into a 12 or 13-inch wide magnitude 10 brace. So it's definitely an industrial strength system. So again, and the earlier slide I showed, you can brace a multi-unit building with a single element on one side or another of the carport or garage. So questions about that, or shear walls in general, or roof trusses, whatever people are interested in.
There was one, I was going to say, there's one in the chat that's directly related to that, I think, which is the bending of the yellow steel size based on the size of the house?
So we have 4 different sizes of the magnitude 10 brace. And the size would be determined by the weight of the structure and how close you are to an earthquake fault. And that's all kind of baked into the engineering analysis that gets done. So hopefully that answers the question.
All right. So we had another one. So and this is more of a fundamentals, why are the hold downs that we typically see, like those Simpson brackets at the bottom of the wall, why are they held up off of the bottom plates?
There's no actual requirement to hold them up off the bottom plates. I believe Simpson says in their literature that you can install them, I want to say 18 inches off the floor. It might be 12 inches. But they can rest right on the mud sill or the sole plate if you want to, and it will still perform just as well. One thing to keep in mind is that when you tighten the nuts on the anchor rod that's coming out of the foundation, the hold downs will actually stretch a little bit, and the connections will sort of deform slightly. So as you do that, it's nice to have a little bit of space underneath the bottom of the hold down bracket so it can actually sort of preload the hold down a little bit.
Does it make a difference what direction we put our plywood on a shear wall?
Theoretically, you get a little bit less deformation of the shear wall if you orient the sheets horizontally. That reduction in deflection is probably not worth concerning yourself about. I'd say it's better to make the installation as easy as possible for the people that are doing the work in the field. And that's going to be to orient the sheets vertically so that you can nail the top edge to the top plate and the bottom edge to the sole plate. And you don't need to have a row of horizontal blocks along, at the 4-foot level, which you'd need if you orient the sheets horizontally. So I would say orient them vertically and just make it as easy as possible to install them.
Sense.
I like that answer.
Another point is that some engineers will show the sheets with staggered joints. So even oriented vertically with the joints staggered, and particularly if you have like a multi-story wall where you might have a 2-story living room area or something, and staggering the joints, again, in my opinion, it's just not worth it. But if the engineer says so, you need to do it. It's it's just kind of embarrassing what I see engineers call for, because it's really easy to draw some of these things. It's not quite so easy to build them.
I like the inclusion of multiple factors of protection: the manufacturer's protection factor, then the designer's protection factor, and then subsequently the authority having jurisdiction's protection factor. So we have about a 40 to 45% protection factor by the time we're all done. It's very, very cost effective.
And that's one of the things that I saw on these code development committees. We were trying to come up with guidelines for strengthening existing houses against earthquakes. And you get 3 or 4 different levels of review, and everybody says, okay, well, let's just add this little safety factor, and my organization will sign off on this. And so pretty soon you've got 4, 10 or 15 or 20% safety factors. And the overall effect is you have twice as much hardware as you actually need. So it's tremendously annoying for an engineer it's my job to calculate the supposedly the right number of anchor bolts or whatever that you need to put into a seismic retrofit and not double that. So, engineers, we really are supposed to give you an economical design. Sometimes the economical solution is to have a so-called pre-engineered design, which is the paint by number type of retrofit following the prescriptive guidelines. So you save money on the engineering and you spend it on extra hardware that probably is unnecessary.
Travis, what I just heard is for us field guys, we've been right this whole time. They're just throwing more hardware at it just for the heck of it.
As long as you're cost plus, Ben, don't worry about it. It's only the client's money, right?
A friend of the show, Steve Demetric, said something recently that he's an anecdotal engineer, and I think I fall into that category too. At what point do we need to worry about making holes through shear walls? Is there any sort of kind of rule of thumb on when we need to make a phone call and say, hey, is this too big?
Hopefully there would be some notes on the plans about that. If you flip to the back of the plans where all the fine print is, I would usually not worry about a nice, neatly cut 6-inch diameter hole. And when I say neatly cut, I would hope that that's just a circle. Overcuts for electric boxes and stuff like that can get to be really nasty for, somebody just overshot with their circular saw and you've got a really nasty cut.
And that's because of propagation, right? That's the risk is that overcut is going to propagate into a failure point.
Yeah, the plywood or the OSB will tend to sort of rip along that cut. I should also point out that the nails are often the weakest point in the plywood shear wall system. So worrying a huge amount about holes or small notches in the plywood, that's really not going to be the failure point. As long as you've got, if it's decent quality plywood, it's probably going to hold, and the nails are going to be the weak point. So if you think about it as, and I don't, there are a lot of builders that, if they're in wind country or lower earthquake zones, they're not accustomed to seeing nail spacing that's closer than 6 inches. But you can, for a serious shear wall, you might have nail spacing that's at 2 inches along all the edges. So the way to think about it is if you have a notch or a hole that's less in diameter than the edge nail spacing, you're probably okay. You probably don't need to worry about that. So if you've got a shear wall with 6-inch edge nail spacing, I wouldn't worry at all about having a 6-inch circular or square hole in that wall.
That's tremendously useful. Can you clarify if the failure mode is the shear of the nails themselves or literally the plywood tearing off of the nails, like pull through? When you see these things fail, how do they fail at the nails?
So there are a couple of ways that the shear wall tests the nails fail. One, and the worst actually, is tearing out the edges of the plywood or the OSB. So if you want to make your shear walls a lot stronger, the easiest way to do that is to hold the nails back at least 3/4 of an inch from the edge of the panel. And that might mean that you're using, say, 4x4 studs at the panel joints, and probably 3x4 bottom plates or mud sills, which at least on the West Coast, it's finally easy to get 3x material. I have no idea. How about back east? Can you get 3x? No. Okay.
No, no such thing here.
Not available in the
We can
Midwest
rip, we
either.
can rip a 4x4, but
Yeah, you could use a 4x4 mud sill or sole plate. It's going to take some longer SDS screws or something to hold it down. But that'll be the pretty bomb-proof way to go to get a really strong shear wall. The other way that nails can fail is actually by pulling out of the framing, and that's at the really far ends of the testing when they might have racked the wall 4 inches out of plumb. But that's another failure mode. If you have crummy thin plywood or OSB, that's also it can actually start to tear when it's that thin. 3/8. They actually used to use 5/16 plywood for shear panels, which I hope they don't even make that anymore. But
Do you see a difference in, or I guess maybe this is not something you've tested or run across, but I'm curious. We often talk about the different qualities of commodity OSB versus, say, a zip system versus, say, a 1/2 inch or 7/16 plywood, CDX, things of that nature. Do you see different performance in those different assemblies?
I do, but like I had to just enclose a project that was bare framing, and I had to just create a shell as quickly and cheaply as I could. So I went to a big box store and got some OSB, and I swear if you breathed on it, it swelled up about 20% in thickness. So when you get OSB exposed to water, it does want to swell up. It will swell up and look like the nails are overdriven in the OSB. I actually worked with somebody who, a professor at Washington State, had a grad student test a bunch of those connections where they nailed OSB to framing, threw it in a bucket of water for a week and tested it. And according to him, the strength of that connection did not change. And his explanation was that the OSB it's compressed wood to begin with, so it's more dense than plywood would be. And as it swelled up, the difference, so the one difference, I said it looks like an overdriven nail, but if you start out with 7/16 OSB and your nail's driven flush, and then the OSB swells up to 5/8 of an inch, you've still got 7/16 of an inch that's bearing against the shank of the nail. So you really haven't, it's not the same as overdriving that nail by 1/4 of an inch. So you according to theory and this guy's testing, you don't lose strength when the OSB swells up. Overdriving the nails is a big problem, because at that point, if you overdrive the nail 1/8 of an inch in a 3/8 inch thick panel, you've lost 1/3 of the bearing of that OSB against the nail. So might have drifted a bit off topic there, but that's
So
Yeah, because now I want you to get the column back out too and show it now that you're bigger on the screen.
I was okay. I didn't realize it would have just been a thumbnail.
Yeah.
I don't
Before
have
we
one
go
of
to
those in my
trusses.
office. That's awesome.
well, one of those in my office.
Yeah, that's awesome.
This would be a structural steel column that gets embedded into a new footing. And the yellow piece is it's called a structural fuse, just like an electrical fuse, where it's built to fail before anything else does. And so as the structure up above that's connected to it slides back and forth in the earthquake, the structural fuse is absorbing all the earthquake energy. And then after that, you can undo the 3 bolts and replace that piece. And you're good for the next earthquake that might be 100 years from now. Or
That's cool as hell. Do you have one of those for roof trusses and stuff like that? We need them everywhere, right? If you're in seismic areas.
Yeah.
So I'd love to sell them for, those pieces for more components, but I'm not sure that it would really make economic sense to be putting them in a lot of different places in a building. So that brace, the magnitude 10 brace, is about a $10,000 item, the hardware. So, and then
I got introduced to him by one of the posters formerly of the JLC forums, who installs quite a few of them in the Bay Area, and got to see kind of what goes in. Like, there is a substantial amount of rebar work placed in that, essentially a grade beam, so to speak. And it's pretty intense, but I understand that, when you're dealing with a client that's like, we're either losing our garage under the house or we're paying to install this item, it seems like it's a pretty good value for what it does.
Yeah, and the space is definitely at a premium in most Bay Area garages. The Simpson strong frames, they're pretty bulky. And as one contractor put it, they're fine if you want to disassemble the house and then reassemble it around the strong frame. But that's kind of your option if you've got a
Seems reasonable. Good hourly work.
Right. But yeah, the footings for these things take some pretty serious rebar, and you're not going to be picking up number 7 or number 8 bars and bending them on site. You need to get that from a rebar fabricator, which just means another phone call and sending them drawings for it. It's not difficult.
Do you normally install just one?
The idea was that you could solve most retrofits just using one. So many people are accustomed to seeing a steel frame, the Simpson moment frame that has a column on either side of the garage and a beam going across the top. They kind of look at me skeptically, like, you really only need one? And it's like, I'm glad to sell you 2 of them, but probably you only need one. So for larger buildings, like, if you get above 4 units or something of apartments, you might need more than one. And of course, getting into the 40-unit buildings, you're going to need several of them.
It's an opportunity for salesmanship right there. You just say, you double the price, and then you tell them, hey, it's a 2-for-1 special today only. And then, you're just slinging these all over town. It's a value proposition. Don't miss your chance. Get in now.
I should bring you to on the sales team here.
How do you like not making money? I have a lot of expertise in losing money. I might be a great partner for you.
I sell low, the Travis Brungart story.
That's right.
David Gerstel asks if 10K is just for the device, or is that for everything altogether? Like
that's for the device itself. Yeah. So contractors seem to be charging about 25 to 30,000 to put in a brace with the footing and the labor and the connections up above, and patching some drywall probably. You could spend half that much if you're needing to install a steel frame and you run into a gas meter or an electrical panel on one side of the garage or the other. You have to move that, and you haven't even done anything structural yet. So when you can avoid that by putting a brace just on one side of the garage, you're a lot better off.
What's the cost of the yellow piece if you have to replace that after an event?
So We have not
It depends.
yet had somebody who wants to buy extras of those. And it's probably going to be about $2,000 for a set, because that's really where all the intellectual property is in those pieces. So, it's like if you think about a silicon chip that goes into a calculator or a computer, the value of the silicon in there is a few cents, but getting it to work right is where the hundreds of dollars come into the value of that chip.
That makes sense.
Very cool.
So, are there common areas where you see contractors make mistakes in shear walls, or common areas where you see engineers make mistakes in shear walls that we should watch out for?
Um, the the most common mistake is probably just not taking the time to go back and look at the shear wall once you're done with it. And I've inspected lots of shear walls, and I would just kind of get in the zone, and I'd tell the contractor, well, leave me alone. Don't be talking about the baseball game or whatever scores we're thinking about. And I just look at every panel on the wall, make sure there are nails along each edge at the right spacing. Make sure that the hold downs, if they're required, they're not always required. Make sure that they're installed, the anchors are tight, all the connections are there. But yeah, it's really common for people to omit something so that either the load is not getting to the top of the shear wall, or it's not getting from the shear wall to the foundation. But yeah, there are many things that can go wrong with a shear wall, and it's hard to say which is the worst. 25 years ago, it was probably over nailing, over driving the nails. That was before they had better depth controls on the guns. So I'm hoping you don't see that as much as I used to.
Not as much anymore. I remember those days and those things that weighed like 40 pounds and had no safeties on them.
There was a question about, we've talked a lot about wood frame, but there's different questions about ICFs or even hempcrete, other opportunities for tying these things in.
Are you talking about the magnitude 10 brace or the?
No, I'm not. I'm referring to other moment frame connections. When we talked about like the Simpson hold downs and the other type of mud sill connectors and the straps and all those different other solutions. This is a question from the chat. I apologize. I'm scrolling back through trying to get everyone's questions answered, and so I'm jumping around. I've only had 2 beers. Come on, give me a pass. What I'm getting at is in terms of tying things together. Obviously, I saw your magnitude 10 or your the brace that you showed set in concrete, and that's clear. But what I'm referring to is other options specifically to serve our ICF and hempcrete enthusiasts that are asking in the chat. Do you have any comment or suggestion for that?
ICFs and hempcrete, I've dealt a little bit with fiber adobe, I think they were calling it, where it was shredded newspaper mixed with cement. And I'm assuming that the hempcrete is basically the same thing. It's a bunch of chopped hemp mixed with concrete. Those are going to be, I would expect, in California, they would need to be engineered. And so you need to have some sort of engineering and whatever kind of specific design requirements for that. And the ICFs, again, that's an engineered system where you'd need to be paying attention to specific requirements for the particular structure. So I can't really give anything general on those. If I dealt some more,
That's
maybe
fair.
I'd be able to give you something to watch out for.
But a concrete wall can be a shear wall. It just has to be designed as such, is my understanding. Like we make shear walls in large structures out of concrete. It's the rebar schedule, as far as I understand, that changes in how it performs.
Yeah, yeah. Yeah, shear wall doesn't necessarily have to be wood. So concrete block, and there are all sorts of sort of newish for an old guy. There are new code requirements where you need to have extra bars. Like if you're building a concrete shear wall, you're going to have a bunch of extra vertical bars near the edges of the walls, and those are going to be confined with like number 3 ties around them and stuff. So you get a lot of rebar congestion in those, and they look pretty crazy before the concrete goes in.
I've seen some pictures and it's just like, yeah, how do you fit any concrete in between all that rebar?
Right. Yeah,
So kind of a work of art, some of them, but
yeah, the iron workers on some of those, like where you've got 3 elements coming together, it just is insane in concrete buildings where you got column verticals and then beams going both ways, and number 10 bars that are all running past each other somehow.
oh, here's a interesting one. Will the inclusion of like construction adhesive between the panel and the wood framing improve the performance?
So in seismic zones, that's actually against code because what it does, again, you've got the seismic energy is dissipated by all those nails bending just a little bit as the earthquake makes the wall rack back and forth. That's absorbing energy kind of predictably, and you get some ductility there. As soon as you glue the joint between the framing and the plywood, now you've created a rigid element, and it's gonna resist force until suddenly the plywood breaks loose from the framing, and then you get a sudden failure. So that's the idea behind disallowing construction adhesive. Now, what, to my knowledge, nobody has studied is what happens when you have a plywood shear wall and a framing cavity, and you come and you spray foam in there, which in my mind is just like polyurethane construction adhesive. I don't know.
Interesting.
He belongs on BS and Beer. He brought up spray foam. Oh man.
It's the
adheres at the edges, not so much through the middle. It's not a real strong bond across the volume of it.
Yeah, but that's us drinking beer and thinking of building science, not doing any testing. So
there's your $1,000 idea, Travis. And what I mean by that is it's a good way for you to spend several thousand on an idea and never see it come back.
Our friends at Green Architects Lounge would be proud of you. The $1,000 idea. That's a real letdown, Ben. We usually go at least 6 figures on those ideas. Come on, man.
This is, and I doubt it'll change anything about construction adhesive, but what's the difference between wind and earthquake loads, right? How does the shear wall change if you're not practicing in an earthquake zone?
So as far as the engineering goes, you're going to calculate the forces from the earthquake or from the wind. If you're in California or Washington or Oregon, sort of maybe 150 miles from the San Andreas Fault or whatever your favorite fault is, then you're going to need to check both wind and earthquake loads, decide which one is higher. And then you just go from there, and you're looking up the strength of the shear walls given by the code and applying those values in your design. So you're not really focused that much on whether the forces are from wind or earthquake. In the seismic zones, there are some specific detailing requirements that you get where you you can't use the adhesive for the panel connection. I think in wind areas you can use adhesives, but I don't think they actually give you any increased value in the strength of the wall. It's just, I've never looked at that because I can't do it in California. So I'm, why bother to learn anything that I'm not going to actually apply?
Typical engineer.
Well, and earlier you were talking about water. So is that again different on how you would apply it if you were in a hurricane zone? Because now it's wet and windy.
Yeah, it's not supposed to be wet because cladding is never going to blow off the walls or the roof.
Of course
Of course not.
Yeah, then that oh God. Hopefully that's where the over engineering comes in a little bit, and maybe the engineer adds a 50% safety factor or something, and that will take care of your soaking wet OSB and such. That kind of brings me to another point that I used to hear a lot is, earthquakes, nobody was worried about shear walls and wind zones. And I'd say, okay, look, you got a hurricane or a tornado, those can generate far more force on a building than an earthquake would. And then people would say, well, you can't design for a direct hit from a tornado. And that's kind of like saying, well, I should just give up on my seismic designs because you can't design if the fault breaks loose underneath your building. Like, well, no, and actually you can. It's just a hell of a lot more expensive.
He wants to pay for it.
Right. So we're not necessarily going to design something that can withstand a direct hit from a tornado, but you can certainly prevent damage when the tornado is a block and a half away. And there are plenty of buildings that are in that situation where the winds are going to be strong enough to flatten a building that has no shear walls. And so the direct hit from the tornado is unreasonable to design for, but the tornado going by and flattening your neighbor's house, your house might be spared if you do a good job on the shear walls.
Is it possible to make a building too stiff?
Yes. But what that does is it just, and I should say, it's possible to make an earthquake retrofit too stiff. And when I talk about a retrofit, we're typically talking about the crawl space walls. So if you strengthen those too much, you're just going to transmit the earthquake forces up to the next level. And if there's no strengthening done there, then you could get more damage up there. If you're building a new house, it's really making it too stiff is not going to be a concern typically. It can sort of alter the way the anchorage to the foundation performs, because if you think about it, if you've got a water balloon and if you glue that to a concrete foundation, and shake it back and forth. It's it's going to slosh around. And that's your flexible building. Now you freeze the water balloon and you shake it back and forth. Those connections are going to have a lot more force on them because now you got a really rigid structure. So the same thing can happen with the earthquake or the wind forces if you make it too rigid. So that's but again, if you want a super rigid structure that's not going to deform much, then you just throw in more anchor bolts and more plywood nailing. And
I feel like
making so the rigidity helps reduce damage in an earthquake, because as soon as you get a shear wall is expected to move as much as 2 inches. You'll get 2 inches of racking out of plumb in an earthquake. You start to get cosmetic damage when you're at about a 1/2 inch of deformation. So if you make your shear walls stiff enough so that they'll deflect less than 1/2 inch, then you hardly even know that an earthquake occurred, because you don't have any cracked drywall or trim that's cockeyed or whatever. So it's really inexpensive to do that in the original construction. Might add like 5% to the cost of a house. So why not do that when you can greatly reduce the risk of earthquake damage?
We've got a burning question here from Tim Euler. He says, when can we get a wood frame shear wall construction guide 3rd edition?
Yeah,
this is really why we had you here.
They keep changing the damn code, and updating the book to keep up with the code is not something I'm inclined to do right now. But yeah, I'm thank you, Tim, for all your plugs for the book, and I will I'll keep it in mind for a retirement project.
You should offer to trade him for some custom boots. He's got to connect. I think you should make a deal.
I've still got my 4 pairs of Red Wings from 40 years ago. So
they last forever. It's fair.
Well, they last forever, especially if you don't use them for about 30 of those years.
John reminded us about roof trusses. I'd interpret his question is what is the difference between shear walls and lateral bracing for roof trusses?
So yeah, they're kind of entirely different. The lateral bracing for roof trusses, it's addressed pretty well, and I'm trying to remember the acronym is BCSI, Building Components Standards. There's something, and they finally realized that the people installing the trusses were just treating them as individual, discrete components. But the engineers that were designing the trusses are assuming that a lot of those members are going to have bracing, so they don't, you got a truss. You need to hold it so it's not going to buckle out of plane on you. And that, I don't know how well understood that is now, because I've been in crawl spaces for the last 15 years, not in attics. So I don't know what's going on with the trusses. But it's if you do truss roof construction, you really need to pay attention to bracing the members out of plane where shown on the engineering. So that's a good thing to watch out for.
I can't speak for the industry, but I do know that our truss roof packages now come with much better information on where to do those bracing and strong backs than they did 20 years ago. So hopefully that's helping that to be treated more as a system.
Yeah. And I mean, I haven't framed, I haven't installed any truss roofs, and I've framed very few actual stacked roofs. But as an engineer looking at the bracing requirements, I'm thinking, by the time you install all that continuous lateral bracing, you may have come out behind on the labor savings of the truss package. It gets really complex. So
especially after you add in the crane to hoist those trusses into place and the operator.
Yeah.
It's a bastard, but that's a that's a cost delta that everyone can consider on their projects. Before we lose you, I want to make sure that we talk about screws, because I have long favored screws for my assemblies, and obviously Simpson's rated screws make those sorts of structural connections easy. But with regard to your typical shear wall assembly nailing, is there an advantage to screws? I typically think of shear being less in a screw than in a nail. Can you talk about that a little bit, please?
Yeah, screws are actually not allowed in shear wall construction.
Question. Way to go, John.
You may be able to find a screw that's been tested, but typically they're, and again, the steel, you want that nice ductility. So you want a nail that's going to bend back and forth many times before it fatigues and breaks. And there are so many different kinds of steel used in screws. I mean, drywall screws are really brittle. Depending on if it's GRK or whoever else is making the screw, it may be a totally different kind of steel than what's in a typical nail. So nails meet a particular standard, and you pretty much know that's what you're getting when you're using nails in a shear wall. So the structural screws are awesome. They're like the best invention that I've seen in the last 30 years. But they kind of have their place, and connecting plywood to studs is not that place.
At least not quickly.
Say again?
I said at least not quickly. A nail gun's still a heck of a lot quicker than a screw gun.
Yeah, that's for sure.
Here's a blast from the past. What about staples? You guys remember shear stapling?
I think it's still allowed, but the problem is the staples. After an earthquake, your plywood is slipping past the framing slightly.
Yeah.
If the nails fatigue and break, you'll see the nail head is going to be loose, but the crown of the staple, you might get the wire in the staple is going to break off at a different place than the nail breaks. So you'll get a bunch of staples that have fatigued and broken, and you can't see it. So the concern is more that you won't be able to see the damage after an earthquake. Theoretically, if the engineering is done right and you use the staples and you hit all the framing members, they should perform adequately.
I haven't seen a stapler on site for like 15 years, but when I started, that was common. He's like, "Oh, we're putting down sheathing. Get out the stapler."
There's still sections in Canada where those guys are like machine gunning staples down onto sheathing.
Well, and I actually designed shear walls and more plywood roof diaphragms where we wanted to use staples because we were going over existing wood, and we wanted to use 14 gauge staples because it was going to be a lot less likely to split the substrate than a 8 or 10 penny nail. And as far as I know, that project was too expensive and never got built, so we didn't have to worry about it.
Perfect. I love those jobs.
Yes.
Those are the jobs that let you sleep at night.
Right.
Well, this was awesome. I really appreciate you coming on and sharing this. The chat box was hot tonight. I stopped paying attention after a while because it was going crazy. So hopefully we got everybody's questions. If you didn't get your question answered, make sure you follow up with us afterwards. We'd be happy to ask Thor to weigh in. But thank you, Thor, so much for coming on and sharing your vast knowledge with our audience. We really appreciate it.
All right. Well, thank you. And I don't know if there's a way to send me remaining questions, but if there's anything really that I think really should get addressed, I'd be glad to send you follow-ups on some of those.
Great. We'll make sure we follow up.
Excellent.
Awesome.
Right.
Thank you, sir.
Thank you all. Have a great night.
Thank you.